Welcome back to Nexaspaces, where innovation meets the future. Today, we launch into one of the most exciting frontiers of technology, the future of AIoT in space tech. From satellites that learn to self-repair to AI-controlled rovers on alien planets, the fusion of AI and IoT is making space exploration more intelligent, efficient, and autonomous. AIoT, artificial intelligence of things, combines smart devices with real-time decision-making powered by AI. In space tech, this means connected, intelligent systems capable of sensing, communicating, and adapting, all without human intervention. From nanosatellites to deep space probes, AIoT allows spacecraft to operate independently in environments where Earth is too far away to give commands quickly. Space is extreme, remote, unpredictable, and incredibly harsh. Here's where AIoT becomes vital. Autonomy. Devices must make decisions on their own due to communication delays. Efficiency. Every resource counts. AI helps optimize fuel, energy, and data usage. Resilience. Smart systems can detect faults and reconfigure themselves. Without intelligent automation, missions like Mars rovers or deep space probes would be nearly impossible. Let's look at some real-world applications already in motion. NASA's Mars rovers, equipped with AI for autonomous navigation and decision-making. Satellite swarms, like SpaceX's Starlink, where thousands of satellites communicate and self-manage via AIoT protocols. AI on the ISS. Systems like Simon, the AI assistant aboard the International Space Station, use machine learning to interact with astronauts and monitor systems. These are just the beginning. Here's how a typical AIoT system works in space. Sensors collect data, like temperature, radiation, fuel levels, structural integrity. Edge AI processes that data locally, without needing ground control. IoT network shares that data across systems, satellites, or back to Earth. AI engines learn from patterns, for example, predicting solar flares or meteor strikes, and take action. This architecture is what enables deep space autonomy. One of the most impactful AIoT applications is predictive maintenance. AI can predict when a component is likely to fail before it actually does. On a spacecraft millions of kilometers from Earth, this is a literal lifesaver. Imagine a solar panel degrading. The system reroutes power, alerts mission control, and reschedules tasks, all on its own. This not only increases mission duration, but also drastically cuts down risk and cost. Satellites are no longer just passive objects. They're becoming smart, connected, and autonomous. With AIoT, satellite constellations can adjust their orbits to avoid space debris, optimize network load sharing, and even collaborate to create 3D Earth maps or detect climate anomalies. We're entering the age of satellite intelligence as a service. AIoT is playing a major role in monitoring Earth from space. AI-enhanced satellites can track forest fires, glacier melting, or ocean pollution in real time, trigger early warning systems for natural disasters, and help in climate research by detecting long-term environmental patterns. The result? A smarter, faster response to Earth challenges. But of course, this frontier has its challenges. Radiation damage to electronics, latency and limited bandwidth, power constraints, AI model reliability. A wrong decision in space can be catastrophic. And finally, security. What happens if an AIoT satellite gets hacked? These are the barriers we need to solve before we go fully autonomous. Looking ahead, AIoT will be the backbone of missions to the Moon, Mars, and beyond. We're talking about self-managing Martian colonies, AIoT drones exploring Titan's atmosphere, 3D printed, sensor-rich habitats that learn and evolve, and even asteroid mining operations managed by AI fleets. AIoT will allow us to explore deeper and survive longer in space, without needing constant human control. Some of the key players driving AIoT in space include NASA, with their AI-enhanced mission planning and rover tech. SpaceX, using AI for rocket landing, satellite management, and reusability. ESA, European Space Agency, exploring cognitive satellites and AI ground systems. Startups like Swarm Technologies, Planet Labs, and Orbital Insight are also pushing the envelope with miniaturized, intelligent satellites. In conclusion, AIoT is not just helping us reach space. It's helping us thrive in it. It's turning spacecraft into thinking machines. It's enabling interplanetary missions that learn, adapt, and survive. And it's giving us a smarter eye on our own planet. At Nexaspaces, we believe the future of AIoT in space is not just promising. It's essential. If you enjoyed this journey, give us a like, drop a comment, and subscribe to Nexaspaces. Tell us, what excites you most about AIoT in space? Stay tuned for our next video. Until next time, keep reaching for the stars.